Hello, you are once again welcome to Integrated Science Intervention Program for Senior High Schools. Today's topic is Variation and Inheritance, and the lesson title is Sex Determination in Humans. I am your facilitator, Gilbert Odey Into. Now, for a starter, let's look at the two persons on your screen. Let's observe them carefully and state two features of them. You have just 5 seconds to do that. Now your guess is as good as mine. Looking at them, one is a male and the other is a female. Again, they both have brown skin. They also have black hair and also have big eyes. Let's limit the features here. Today, our lesson will dwell more on their sexes. In the lesson, we'll look at how sex is determined in humans. For our lesson outline, we'll look at sex determined in humans. We'll also look at sex-linked characters, and finally look at sex inheritance in humans. Our keywords are autosomes, sex-linked character, X and Y chromosomes, color blindness, and hemophilia. Now let's begin with sex determination in humans. The body of humans have cells, and in the nucleus of the cells are 23 pairs of chromosomes. That is what you can see on your screen. 22 pairs of the 23 are similar in both males and females, and they control the various body characters apart from their sex characters. These 22 pairs are known as autosomes, and like I said, they control the body features in both males and females. The 23rd pair, which determines the sex of the individuals, are known as sex chromosomes. These pairs are different. One of them is long, and this one is termed as X chromosome, whilst the other is short. The short one is also termed as Y chromosome. The male has one long chromosome and one short, and hence they are controlled by XY chromosomes, whilst the female have two long chromosomes and hence are controlled by XX chromosomes. Now coming to sex determination, we have the mother and the father with their chromosomes. The mother has two long chromosomes and hence it is termed XX, whilst the father has one long and one short chromosome, which is termed XY. In the formation of their sex cells or gametes, the female produces eggs, which contains X chromosome because they only have the X chromosomes, whilst the male produces two different sperms, one containing Y chromosome and the other containing X chromosome, as you see on your screen. During fertilization, if an X-bearing sperm fertilizes the egg, since the egg is X and the sperm also bears X, the zygote that would develop from these chromosomes will have XX chromosomes and hence would develop into a female or a girl. If the Y fertilizes the egg, the zygote will bear XY and will develop into a male. Now let's come to genetic cross diagram of sex determination in humans. This is what you will need for your exams during WASSCE. We have the mother and the father crossing, and that is the parental phenotype like we studied in our previous lesson. Their gametes are XX for the female and XY for the male, and that is also crossing, so we have the crossing sign between them. Then when it comes to the formation of their sex cells, they separate, and that of the male also separate. So we have X separate and X separate in the female, X and Y separating in the male. These are circled to show that they are sex cells. Then when it comes to their crosses, if X chromosome takes the X, we'll have XX zygote, and that will develop into a girl. Again, if the second X of the female takes the X of the male, we'll still have XX and will develop into a girl. Then when we come to the X of the female and the Y of the male, we'll have XY, which will develop into a boy. Likewise, the second X of the female taking the Y of the male, also forming XY and developing into a boy. Now, let's look at the children. We have 2 males and 2 females. It doesn't mean when they give birth, they will give birth to 2 males and 2 females. But the chance that in every birth, they will give birth to a boy or a girl is in the ratio 1:1 or 50%. That means they have equal chance to occur. So the chance to give birth to a boy is the same as the chance to give birth to a girl. Now, when it comes to sex determination, the sperm that the father produces is very important. That is, looking at the fertilization, it is the sperm of the father that determines the child sex. If the sperm bears X chromosome, then the child will be a girl because it will combine with that of the mother, which is X. If the sperm bears Y, again, it will combine with the mother's X, which will form XY, and that will develop into a boy. So it is the father that determines the sex of the child. So anytime you hear quarrels between couple looking for male children, like we know in Africa, advise the man to keep quiet because he determines the sex of the child. Now let's look at sex-linked characters, which are characters that are linked to some of the sex chromosomes. Let's define the term sex-linked character. This is a character that is controlled by a recessive gene. That means a gene that does not occur frequently in population. This gene is found on the X chromosome, but not on the Y. So it is absent on the Y. It is only found on the X. Let's look at the scenario on your screen where we have 2 chromosomes, one being long and one being short. And like we studied already, the long one is X and the short one is Y. So considering sex-linked characters, you can see that we have it only on the X, but the Y doesn't. And here it is represented by small letter. And from our previous lessons, we know that small letters represent recessive. Hence, that person will have the character. Another one is long and short chromosomes, where it represents X and Y. But now on the X, we have a capital letter showing that it has a dominant gene and hence will not have the character. Now let's come to the females. The female has 2 long chromosomes, which are XX. In the scenario on your screen, we have one of the X having capital letter and one having small letter. This shows that the person has both the dominant gene and the recessive gene. But because the dominant gene is there, that person will not show the character, and hence we say that person has the trait for sex-linked character. Then the third scenario is where we have 2 long chromosomes and hence it represents XX, which is a female, but they both have small letters, showing that they both have the recessive character. And once 2 recessive genes occur on a pair of chromosomes, it shows in the person. So that female will have the sex-linked character. This character is more common in males than in females, so you hardly see females showing them. This is because the males need only one of that recessive gene to show, unlike females that need 2. And let me ask you, if they say go bring 1 chair and another person should go and bring 2, which one will be easier? The 1. So normally the 1 occurs more than the 2. That is the reason why females don't normally show it, because they need 2 of these recessive genes to show, unlike the males that needs 1. Now let's see some examples of the character. We have hemophilia. Hemophilia is also known as the bleeder's disease. Such persons can bleed to death if they get injured. That means their blood fails to clot to stop bleeding. And that is what is termed as hemophilia. It is one of the sex-linked characters. Another one is baldness. That is premature loss of hair. It can be in early ages or old age, but it is controlled by a recessive gene which is found on the X chromosome but not on Y. And like I said, it's more common in males than in females, so more males are bald than females. Another one is red-green color blindness. Like you see on your screen, we have 3 apples on top. Those 3 apples are green, yellow, and red. Colorblind people cannot distinguish between the colors green and red. They see them as brown or yellow. So looking at how they see below, you see that the first apple that is green appears to them as either brown or yellow, but the yellow one appears as yellow, whilst the red appears as brown or also yellow. Then finally, we have hairy yellow. Some people grow hair on their ears. Yes, you see it clear on the screen that on the ears are hair, which is not common in females, but males show them. Now let's see a cross between mother who is a carrier of baldness and a non-bald father. That means though the mother is not bald, she carries the gene for baldness, whilst the father doesn't carry and hence is not bald. First, we have phenotype of parents, which is carrier mother crossing with a non-bald father. So father and mother are both non-bald, but the mother carries the gene. Now we come to parental genotype, where the mother has XX, but it is only one of the X that bears that character, which is the one with small b. The other one with small a is dominant when it comes to that character. Hence, that woman will not show, but will carry it. For the man has X, Y, and we say the man doesn't have the character. Hence, the man's X will bear capital B, which is the dominant for that character, but the Y will not bear because from the definition, Y chromosomes don't have sex-linked characters. Now we come to the gametes. For the gametes, we know they separate, so the X with capital B separates from the X with small b. Then the X with capital B in the male separates from the Y. And please remember, Y doesn't bear it. Then we circle them to show that they are sex cells. Then crossing of the sex cells, when X capital B takes the X capital B of the father, we'll have XX, which will carry capital B's. Again, when the mother's X that carries capital B takes the Y of the father, we'll have X capital B and Y. Then secondly, the mother's X with small b takes the father's X with capital B. We'll have X capital B, X small b. Then finally, the X small b takes the Y, which will be X small b and Y. Now we come to offspring's phenotype, where the first one having X, X, and hence will be a girl, but carries two capital B's and hence will be a non-bald girl. The second being XX, which will also be a girl, but one of the X carries capital B whilst the other carries small b, leading to a female which will be non-bald but will be carrier of baldness. Then the third one will be XY, leading to formation of a boy, but since the X carries capital B, that boy will be non-bald. Then finally, we have a bald boy where the X carries small b, which is recessive, and hence that boy will be bald. Looking at the scenario, we see that the boys inherit X from their mothers and not from fathers. And hence, sex-linked characters are obtained from mothers, but not fathers, by the boys. So if a boy is bald, it doesn't mean the father is bald, that is why that boy is bald. But it means the grandfather, who is the mother's father, is bald. That is why the mother got the baldness and transmitted it to the son. So in this case, if a father is bald and the maternal grandfather is not bald, none of the sons of that mother will be bald. Now let's see what we've done in this lesson. We looked at sex determination in humans. We also looked at sex-linked characters and how they are inherited. Now, for your assignment, try your hands on this question. Use genetic cross diagram to show the phenotypes of the children of a homozygous normal vision mother and a colorblind man. Do try it, and remember that X are the only ones that carries the sex-linked characters and not Y. And remember, since it's a sex-linked character, anytime you are doing the genetic cross diagram, you should remember to bring the sex chromosomes. All too soon, we've come to the end of the lesson. See you another time.